Hi, it's Mike Stevenson. In today's video, we're going to talk about the next in the series of understanding Azure costs, and we're going to talk about Logic App Standard. So today's session, we're going to do a deeper dive on the talk I did at the Nordic Integration Summit, but this time focusing on Logic App Standard costs, and we're going to try and understand what is it that makes up the cost, what are the architectural decisions that I might make that affect cost, and how can I tune costs. Before we jump in, a quick sort of shout out for Turbo 360 who support the channel and help me grow the channel. So if anybody's interested in cost management tooling, please check out what they offer. So let's work through this list of things that relate to cost management for Logic Apps. So the first thing we're going to look at is what makes up the cost of my Logic App Standard. So here I've got an example, and we're going to talk about what makes up the cost here. So in the Logic App Standard workflow, there's really two elements. There's a static cost and a variable cost. So in Logic App consumption, we know that all of the costs are variable based on the number of runs that you have. But in Logic App Standard, our assumption is that everything's about the app service hosting plan, which is true to a degree. But what we sometimes forget is that there's other costs for things like cloud connectors, for logging, and for storage. And we need to remember that those costs do contribute to the overall cost of our Logic app. And actually, some of those costs would be variable. So in this case here, imagine we've got a stateful workflow with 100 shapes. 10 of those shapes use the Dataverse connector. So what would be making up that cost for that workflow? So the first thing is going to be the hosting plan. So here we've got per second billing for an app service or an ASA, paying for the compute for that plan that will pay, imagine we have the plan running 24/7 for a month, and we're going to pay a fairly static cost for that hosting plan. Now there may be variance if we scale it temporarily, we scale out to more nodes, but in general it's going to be a fairly static cost. But when the workflow's running, there'll be some variable costs come into place. The first one's going to be these connector costs. So one run of the Logic app workflow is going to make 10 calls to Dataverse. Each of those calls to the cloud connector for Dataverse is going to incur a tiny cost. So if we just do one run, you probably wouldn't notice it. But if we do thousands of runs, you might start noticing that billing item on your bill starts building up. The next thing we're going to look at is the log events. So the chances are with Logic App Standard, you probably have App Insights configured for telemetry. So there's going to be a few things that are going on here. So number one, you're going to have traces, requests, and dependencies, and also metrics for things like the performance of the plan are going to go into your App Insights to give you that application performance management capability. Now each of those log events are going to incur a tiny cost, and what you would find in this case, this one where we've got 100 shapes, so the minimum we're going to get is going to be an event at the start and end of the workflow, and then an event for the start and end of each action are all going to go into the log. So that's going to be, in this case, there's going to be 200 plus of events go to the log for one run of the workflow. So as that scales up and we do more runs, that logging will start becoming noticeable, and you may need to tune and manage that. And we'll talk about some of those tunings later. Now, the workflow again, there'll be persistence points on the workflow. So it depends what shapes you're doing as to when it'll persist to the storage. But the chances are with a stateful workflow, in this case, we could have as many as a couple of hundred storage transactions, persistent each time the workflow engine gets to a point where it needs to be recoverable from. So that's going to be saving data to storage and picking up the next action from something like a storage queue. And that's all going to be handled internally in the workflow runtime. And then finally, we're going to have things like data transfer costs will come into play for our workflow and the storage interactions as well. Now, if we take a look at an example, so here I'm looking at the costs for a logic app standard. This one's not heavily used, so we've got a fairly static cost here. And this big blue item you can see is the app service cost here. So if I remember right, this was an ASC logic app. Now the WS star plans 1, 2, and 3, they can be more burstable than what an ASC can, but either way, you're going to have a fairly static app service cost for your logic app. Now, if you notice on the top here, we do have some cost for the storage. Now, as I say, it's not a heavily used logic app, this one, so the storage costs aren't big, but that'll be the workflow runtime interacting with a storage account to persist the state of the logic app and control the execution. And then if you notice, the costs for the other two pieces are really small in this case, but we have Defender and bandwidth showing up. So these are the kind of the service types showing up as cost for my logic app in this case. Now, I think I'm probably within the free tier of app service in this example, so it might be the case that I don't have any app service costs showing up yet, but you're probably going to expect to see some of those later on. Now, if we go level down and start looking at some of the meters that are being used within those costs, so the isolated plan here, this is going to be the cost of that app service because it's an ASC, but the storage costs will break down a bit more. So if we see the purple bit here, that's going to be table costs in Azure storage, and then we have queues here. So we're going to be interacting with queues and tables quite a bit for this workflow execution. So they're the primary drivers. There are a few other really small costs that you can't see at this level unless we scale down into a bit more detail so we can look much finer. But that's a view of the costs in this example, sort of month worth or last 30 days worth of data. Now, if we look at the individual costs, so I've gone down again a little bit deeper and I'm just looking at the storage costs. So you can see, again, we've got here we've got the big table storage and the queue storage taking up most of it. I mean, in this case, it's not a big cost overall. We're talking less than $1 a day. But this shows you just in a little bit more detail how we've got a little bit of storage for blob coming into play, and a little bit of file storage cost there. So the file storage is probably the mountain of the logic app onto the app service plan, and I guess the blob storage might be things like message bodies, I would guess. But just be aware that there's more of these costs. In my case, they're really small, but in your case, if you've got a production workload with high volume, they're probably going to be bigger. So you want to kind of just be aware of all these different things. Okay, so if we go back to our table, so we've talked about what makes up my logic app cost, and hopefully that was quite interesting for people to see that it's more than just the app service. Now, let's start thinking about some of the other things that I'm thinking about when we design how we're going to build our logic app solution. So here the first question is, how are we going to host it? And I touched on this a little bit already. So we've really got this choice for an app service between an ASC or a WS 1, 2, and 3. And really, there's a few different feature differences. So particularly the ASC offers simplified networking. But either way, when it comes to cost, really the key difference is about the ASC is typically more expensive for one node. You can mitigate some of that when you apply reservations to it, for example. I think the other thing to note is probably that the WS 1 and 2 plans are probably aimed more for non-production workloads in my experience in the past, because I just find the performance really needed me in most cases to end up with a WS3. Now, the key thing in costs probably comes down to when you scale. So you can't really scale bigger than a WS3. You can go to a bigger ASC. So if you want to scale up, there's more options on the ASC. The WS3 plan, or the 1, 2, and 3, will have more burstable bits. So if you've got sort of really intermittent workloads where you have big spikes, that WS3 plan would have some advantages there, but just be aware that there is two options. If you probably, my gut feel is if you want a more predictable cost and workload, I think the ASE with the reservation is quite a good choice. And if you've got more sort of burstable intermittent load workloads, you probably want the WS3. And I think there's combinations of those that people might choose depending on, probably on the next point, actually, the apt plan placement. So we've covered that. Now, the next question, this apt plan placement, this really came up as a big question at the Nordic Integration Summit. And I'm going to touch on this with a new slide, I think, to talk about this a bit more. So the question we had from one of the guys at one of our partners was, I've got 100 logic apps. How many plans should I need? So really, if we imagine conceptually, people probably think, well, I need an app service plan, and I've got some apps. So let's say we've got 3 apps, and then in my app, I've got some workflows. So let's say we've got 4 there, 3 there, 2 there. Now, the question becomes, how many workflows should I put in an app, and how many apps should I put on a plan? And that's quite a key sort of decision that you're going to make. And there's a number of factors that can come into play. So things like, logically, which ones go together from a functionality perspective, which ones go together from a performance and security perspective, and which ones go together from a cost perspective. Now, when we start thinking about cost, there's a lot of relationships between performance and cost. So the better you get your application performing, it'll either make your cost go up significantly because you're getting higher performing tiers, or it might make your costs go down quite a lot because you're getting better efficiency on the compute nodes that you've got. So it can go both ways, but really, typically having it efficient is really what you want to maximize costs. So in that case where we had 100 workflows, the first thing to think about was, if I have one node where it's got 100 apps with multiple workflows per app, that probably has to be quite a powerful node just to run the apps on before you start processing any messages. So if you think a lot of these logic apps, they're going to spin up into memory, they're going to have the .NET runtime on them, they're going to need some compute power, and they're also going to be pooling storage. So if you remember, we said each one will have the workflow runtime, and it's going to start querying out to a storage account to see, is there any work for me to do? Have I got any messages to process? And you might also have a scenario, let's say this app here is reaching out to service bus and listening for a queue. So even when you have scenarios where you're not actually processing any messages, the workflow runtime behind the scenes is still going to be doing work. So it's quite conceivable that a plan with 100 apps on could get really busy without it actually doing any work that adds business value. So that idea of moving things out to different plans becomes probably quite a good idea. So let's think of an example. Let's say for argument's sake, I've got a WS3 and I've got 100 apps on it. So the chances are on node number 1, all these apps are going to be probably in memory. They're going to be sitting there waiting to do stuff. They might be triggering off different inputs, so some might be passive HTTP, others might be active Poland service bus. So this is going to be doing quite a lot of work. Now, the question would be, right, let's say we start getting resource constrained and we add another node. So now I've suddenly got 2 nodes with 100 apps each on them. Now, there are some configuration settings that you can configure. So you could have things like pre-warmed instances. You could have things like, there's a config setting where you can say this app can only run on 3 nodes. And if you burst out to 5, that app will only run on 3 of them. But you don't have the explicit config that you got in BizTalk world, where you can say explicitly, this app only runs on node 1, 2, and 4, but not 3, 5, and 6. You don't have that fine-grained control. But so what this means is that if I've got one node that's really busy, I might expand out to 2 nodes, but because we're scaling out, not up, it might be the case that I just end up with 2 busy nodes. So there might be a case, if you think of the cost angle, so we're paying for two, let's say we're paying for two mediums, it might be better if I went to 1 times large. I might find better value for money because I might go to two mediums but not get that much of an increase in performance, and one large might even be cheaper in some cases, but it might give me more performance and I've got more capacity to do more stuff. Now, there's also the question here about things like the ASE versus the WS3 plan. So the ASE's typically got more compute and more memory on it, but also you can go to those bigger plans as well. So that that might influence your decision there to maybe pay a bit more for the ASC, but put a reservation on it to make it cheaper and that kind of thing. What I think, coming back to the original point about placement. So when you've got, it's quite easy when you've only got, say, 3, 5, 10 logic apps, but when you get to that 100 scenario, I think that's a really kind of key thing about multiple plans. So I'm going to give myself another screen here. So what I might do is I might say, let's keep it really easy, and we'll say we create 3 plans. So I might have, now each separate plan can be different SKUs, so I might have a WS3 here, and I might put all of my logic apps. So let's say we've got 1, 2, and 3. And these are all logic apps that would be really, would work really well with burst scaling. So under load, let's say app 1 starts getting hammered, and we might go add extra nodes here, go out to 5, and then 10 minutes later we deflate back to 1. Now, the next one might be, I might have, say, so let's say we've got app 4, 5, and 6. And these might be really low apps, that are like low usage apps. They don't really do a lot. I might put these onto say a WS2, and I might do something like let's say these just run once a day. They do some overnight batch work. They're generally not doing very much, and what we might do is we might automate scaling that up to a 3 for an hour at night, and then scale it back down to a 2 or a 1 when because we know these are all batch jobs that run overnight, and we can keep them scaled down for most of the rest of the day, so we can get more efficient use of the plan there by taking advantage of scale up, scale down. And then I might have, let's say we've got an ASE here, and we might have another 3 apps here, and this could be maybe our more general purpose where we want that, we want maybe 1 or 2 nodes on the ASE that just does most of our, fairly middle ground activity where we've got things, just executing all the time during the day. We want that fairly predictable level of performance. We're not worried too much about burstable load. And we'll just have, I guess the general rule would be most of our stuff would go on this by default, unless it was really intermittent usage, it might go here. And if it had burst requirements, it might go there. And I think that's how you could spread it across multiple plans. And in this case, I've only really used an example of 9 apps, but if you imagine, that out of our 100 apps, that might be 30 of them live here. You might have 10 of them live here, and you might have 60 apps live here or something. And you've just spread your apps out a bit, and maybe we decide, actually, instead of going, we might find, we're starting to get resource constrained here. So our choices would be scale up, scale out, or we can go, I'll put in brackets, nodes, or we could do scale out, and in brackets we could actually add another plan. So we could take, say, 20 or 30 of our apps and move them to a separate plan. And the cost between adding another plan versus scale up or scale out, there's probably not a huge amount in it, but it's just about taking the money and the resources you're using and better allocating them for the workloads that you're trying to run. So I think really the key thing is it depends a lot in this question. How many app, what's my placement of app to plan? Depends on understanding the big picture of what you're trying to do. And there's definitely a bit of an art of choosing the right one for the right job. But I think the great thing with Azure is it's easy to provision infrastructure that you decide you don't need and get rid of later. And it's easy to move apps around, which means you've got a lot of flexibility to decide that decision I made last month didn't work. Let's move it and do it on a different plan. That would work quite well. You're not like you would be in BizTalk world where you've got that capital expense to buy a server to add it to your server farm, and then you're really kind of stuck with the decisions you made. I think the flexibility of Azure lets you get the best value here. Okay, so let's go back to our thing here. So I think we've talked about app placement. I guess we've also talked quite a bit about these three and maybe this one here. So I'll tick these off as well. So burst scale and separate plans and scale up and scale out. Now, the next thing we're going to come on to is connectors. So if we think about the logic app that's running, we've got three different types of connectors really. We've got built-in connectors. I guess there's actually four types. So built-in connectors are going to run on the compute node of the app service plan, so there's no additional cost for those connectors. If we're using a cloud connector, this can be of standard or enterprise type. So an example might be SQL or SAP connector. So we're going to make a call out from our logic app on the app service out to the cloud connector, and there's going to be a separate charge for that cloud connector, and I'll probably do a little bit of an example video showing the difference. That cloud connector is going to be one of those variable costs that depend on how much you're using it, so just be aware that there's extra costs can come into play. We also have API management, so if we have API management already in our architecture, we can proxy different APIs and we can leverage the APIM connector from the logic app to API management. Now, there's no additional cost for using the APIM connector because it runs on the compute node, but we do have a cost for the API management service. That's another case where we have to be aware that our dependencies mean the logic app might have other Azure costs, the same as the storage and the log analytics. If you're using APIM, you're obviously going to pay for that API management resource too. Next up, we've got availability zones and redundancy. So I'm going to add another diagram for this. So here, if we imagine we've got a plan, and let's say we've got two apps on the plan, and we're running with one node and everything's happy. Now, what we can do is we can say, right, we need to improve the resilience of this application, increase the availability, and we've got some options about how we do that. So one of the options is we add an availability. We use availability zones for this. So what this would mean would be in the region. So let's say we're in West Europe. If we turn on availability zones, then the plan is effectively going to have a second and third node. So you would always have at least three. So we've now got this plan has three nodes running, but they're split across data centers within West Europe. Now we've increased our availability, but the trade-off is that we're paying for these extra nodes. So we're now paying for three nodes instead of one. Now the good thing here is that if we had enough load that we needed three nodes anyway, then running those three nodes is not going to be that much more cost than we would have been paying regardless. So that can be quite beneficial for us. But if we only actually needed one node, or we weren't really doing much activity on that node, adding an availability zone is going to move it to three nodes, and we're going to have two of them are going to be idle most of the time. So there's maybe a question again when we think about how do we split out our apps to plans. We might decide that there's some apps that don't need an availability zone, So we put them on a separate plan from the apps that do need an availability zone. So we maximize, as we add apps on the one that has availability zones, we just add the ones that really need it, because then we minimize the number of additional nodes and the scale of that plan needs to be, because it would cost more. Now, the second type of redundancy might be that we need to go cross regions. So if we imagine here we've got West Europe and here we've got North Europe, and we've got our plan, we've got app 1 and app 2, and then we may create another plan in North Europe. So we've got plan 1, plan 2, and we've got app 1 and app 2 on these. Now the big difference here is, in the availability zone over here, we just deploy the app to one plan, and the kind of additional nodes are just taken care of for us. There's no configuration differences. It's really just like a scale out scenario. But here, these are two completely different apps, so they're probably going to have their own local storage, for example. And they're all going to be, they're going to have different config settings in them, and a few other things. And really, you've got, if we think of this as just being one node on each plan, you're paying for two nodes at this point, but because they're in different data centers, you've got that additional resilience, because you can, let's say we load balance traffic somehow coming in. Maybe we've got APIM or something, and we're just splitting the traffic across here. So we've got that cross-region redundancy. Now, a couple of things to think about. So do we need active-active? If we do, these may be things like WS3 plans. If we don't need active-active, we could maybe scale this down to a WS1, and we could reroute our traffic. And then we also get questions, well, what happens if we need availability zones and cross regions? So you might end up, with other copies of the app on other nodes in each local region. So this can get really complicated really quickly. And I think the key thing for me would be, don't just automatically go for the most complex scenario to tick all of the boxes on your resilience requirements. Really challenge the requirement and say, do we actually really need this level of redundancy? And if we do, what's the trade-off in terms of cost? And then decide which way you're going to do it, so that there can be ways you can optimize your design to give you the best efficiency from a cost perspective, but still achieve some of those availability requirements that you might have. Okay, next question is going to be functions or logic app consumption. So this is a more fundamental question. So before we get into too much logic app standard stuff, we might go back and think, actually, was logic app standard the right choice for us? So if we think before, when I talked about having separate plans, and I said I might have a plan where we've got these interfaces that only run once a month and they only do a little bit of work. They have lots of business value, but they don't get used very often. So we might say, in that case, let's take the requirement for resource usage off the app service plan and move that to logic app consumption, because we can free up resources on the plan for other apps that we need to put on that genuinely need those resources. And the consumption apps, we might just be happy paying as you go to run them on demand when they're needed. And actually, I think for a lot of customers, these very ad hoc interfaces, you might get better value for money if you run a split between consumption and standard. So you kind of, any really small integrations just probably are good fits for consumption, and make the standard plan give you value. So if I've got 10 apps, if I can move one of them onto consumption and put a new one on, that might save me having to scale up or scale out that app service plan, so that would be a good cost saving there. Likewise, because functions don't have the durability that the logic app would have, so that, if you think about all those interactions with a storage account, the function's typically going to perform much better, get much higher throughput. So there might be certain integration scenarios where I would choose a function instead of a logic app. I do trade off a bunch of features. So for example, run history, designer, some of the connectors I would sacrifice, but I might find that a certain integration would give me much better value for money being on a function app, maybe with an elastic premium or a flex consumption plan where it can just do a very specific job for me and it frees up my logic app resources for the things that really need it. Let's talk about some of the optimizations now. So here, the first one we're going to look at is login. So we mentioned earlier, if you're using App Insights, you're going to be configuring a lot of login going to your App Insights. So the login, there's really a trade-off of how much of that data do you need to be able to support the application and for the operations side, and how much are you prepared to pay for that. So if you log absolutely everything, you're probably going to find you'll spend a lot of money for log records that you never ever use. But you might be able to tune it down, so things like the host.json or the app settings can be used to turn off and on bits of login. So you might do things like turn it on only when you need it during testing or if you've got an issue, and by default tune it down so it's minimal login. You might leverage things like sampling settings, so you would only log specific numbers of events before you start dropping it just to minimize the cost. You might turn certain logic apps might have more verbose login and other ones might have less verbose. You might do things like turn off some of the metrics and dependencies. So it's really finding the balance around how much login do you really need and are you happy with the cost for that. The next optimization would be stateful versus stateless workflows. So this touches a little bit on the functions thing we talked about before. So a stateful workflow is going to have all of those interactions with a storage account. So there's going to be little costs for that, but also it's going to really have a big impact on the throughput of your app. So that throughput limitation means that you're going to have to scale sooner because you're going to, eventually you'll get enough messages that one node won't be able to do it, so you go to two. Now, if you trade off and had a stateless workflow, you might find that your throughput would go up significantly, and there would be a significantly bigger number of messages to process before you would have to think about scaling. So that's really a good example of when the performance has a direct correlation to the cost. Now, you do obviously trade off some features for stateless, so things like run history you may not have. You might just have to be happy with App Insights logs instead. But if you really need a workflow with all the connectors, that might be a good way of getting a lot more usage out of your plan by leveraging stateless workflows. And remember that you can use these side by side in the same app. So you might focus on some bits being stateful and some being stateless. The next one's storage transactions. So this is where we have our storage account that gets used by the workflow runtime is going to be getting hit quite aggressively by the workflow runtime with all of the check-in for which which is the next action to perform, is there any messages to process and that kind of thing. Now, those will all have a storage cost, but one of the challenges you might have is how do I work out which apps using which storage transactions? And actually, it's not a bad idea to have a separate storage account for each logic app, because that'll limit how you might start hitting throttle and limits on the storage account under load. If if the workflow runtime is scaling out and doing lots of activity, separating your logic apps to use separate storage accounts will help you there, but it'll also help you separate the cost. So you'll be able to, App A uses $10 a month worth of storage and App B only uses $2 a month. That'll be really easy to separate that out. There's also scenarios where you might use multiple storage accounts to shard the data in a really high volume scenario. So just be aware of that as well. Inline function usage, I think, is a really good example. So in the Logic App consumption video, I talked quite a bit about a scenario for filtering data. So if I get a message comes in and I've got a batch of 1,000 rows and I need to get rid of all the rows where the status says deferred. Now, if I do that in a workflow, I'm going to do a loop and I'm going to iterate over it, and I'm going to build a new message and ignore stuff. So in that case, in Logic App consumption, there was a cost for every single action, so we wanted to be really cautious of that. In Logic App Standard, the cost isn't directly for the action, the cost's more for the throughput of the plan. So while we might not have the individual action costs, it's going to take quite a long time by comparison to do a loop through those records and ignore the ones we don't need. And what I can do is just call out to an inline function where I can use some C# to iterate over the JSON object. And especially if it's a stateful workflow, doing that and giving myself the filtered JSON back is going to be significantly quicker. And that's going to basically trade off if I'm under load about how many workflows I can process in a given period of time. That might mean I'm less likely to need to scale, which will then correlate into an increase of cost. So good use of inline functions will definitely help you there. Right sizing's the next one. So right sizing's really where I've chosen the appropriate plan size for the workload that I'm running. So here, my plan might be a WS2, and I might say this is being used too heavily. I need to increase it to a WS3, or I may decrease it to a WS1. Likewise, the same is true on an ASC. You can scale them up and down as well. So that's quite an easy way to get some cost savings. Just make sure that you're checking occasionally the usage and make sure that you're appropriately sized for the work that you're running. Reservations are another good opportunity, so let's put savings plans here as well. So if you're running an app service, there's savings plans for compute and reservation opportunities available. So a good one, I think, especially if you're using Logic App Standard, this is definitely something you should look at. Even if you're burst scaling, you might be able to have a predicted minimum amount of usage that you can put on a reservation. And a savings plan might help you with multiple resources, one of which can be the app service plan. That might still help you in those burst scenarios as well. So I would expect most Logic App Standard customers should be looking at minimum checking your right size and make sure you're efficient, and then make sure you're looking at reservations and savings plans to get the discounts associated with those. And then I think the final one we'll talk about today is workload optimization. So here we might look at things like scale up, scale down. So this would be a case where I can build an automation to say at 9 p.m. scale down my app from a WS3 to a WS1, leave it overnight and scale it back up in the morning to a WS3. And that'll basically give me scale down to save cost when it's not being used. Great use case for a non-prod environment. Scale it up in the morning when we start using it. Now, that's great for your fairly static costs for the app service. One caveat is you can't scale to zero, so you won't be able to stop paying for the app service, but you'll be able to tune those costs lower than what they would otherwise be. The other thing to think about as well is the variable costs we talked about before. So pausing the app or pausing the workflow will mean things like the app will stop checking the storage account, and the app will stop checking things like service bus queues, and it'll stop logging data to App Insights. So it'll not change your app service costs, but it'll change those other costs that vary on the dependency. So your App Insight costs might go down, storage costs might go down, and effectively the total cost of ownership will go down because you're stopping the Logic app. So I think we've covered quite a bit of stuff there. This was this session from Nordic Integration Summit. So obviously I didn't get a chance to deep dive to this level, but I hope people find that interesting. I hope it gives you a bit of food for thought. I'm sure people have got experiences and things I may not have thought about that they'd like to add to this. So please, put stuff in the comments and we can discuss things, questions or other things people think are factored into managing Azure costs for Logic App Standard. Thank you for listening to the video and have a great week.